Okay, so, we have been looking at default reasoning, and we saw the closed world assumption in which every atomic sentence which cannot be shown to be true is made false, and the generalized closed world assumption, which is a little bit more careful in making sentences false, especially when sentences are participating in disjuncts. It will make a sentence or atomic sentence false only if the rest of the disjunct can be made to be shown to be true essentially. But we have dealt so far with propositional logic. So, let us try to see what can we say about, for example, queries which are existential. So, let us go back to our travel database, and we had said that we have some knowledge base which says that some cities are connected to other cities. So, let us say this is a new travel database. See, I do not remember the old one, C A C C D B, and so let us say, and let us say the cities are A, B, C, D and E essentially. So, let us say this is our travel database, or train or airline or whatever, and there is a city E which has not find any mention in this. So, we can see that it is true that this sentence under closure. So, let us not worry too much about the disjunction here, because we do not have one here. We can see that not A D, or we can show that not E A. Sorry?
The connected predicate.
Yeah, I need the predicate there. C. But what about a query like this? So, is this so our knowledge base says that A is connected to B, B is connected to C, A is connected to C and D is connected to B, and we are asking, is it true that no city is connected to E essentially? I think the intuition that you have is that this is true, that there is no city which is connected to E. But you must be careful that this is true only if there is no unnamed city exactly. That maybe we have said that there are these 5 cities and this is a connectivity with them, but we forgot to mention some unnamed city essentially. Now, this is important because we are talking about reasoning under incomplete information. We are saying that we are reasoning under uncertainty, that we do not have all the information. So, maybe we do not even know that there are some cities, let us say as a travel agent you did not know that there was some particular city, let us say Chengalpet or something like that, which is should be part on the travel map essentially. So, while our intention is to say that everything that has not been stated is false, we can say this only if we make a further assumption that the only cities that exist are the ones that are named in our catalog or something like that. This is called domain closure. So, only under domain closure essentially. So, under domain closure we extend the knowledge base to another knowledge base which stands for closure here, which says that it is KB plus was a closed wall assumption knowledge base. In this case we do not have disjunctive sentences. So, we are not bothering about the generalized closed wall thing, but you could use that as well. Union the state sentence that for all x is equal to, in this example, a or x is equal to b or x is equal to c or x is equal to e. So, such a statement which says that the only values that a variable can take are given in the following statement, which says that for all x, x must be either equal to a or it must be equal to b or it must be equal to c or d or e. This statement is called domain closure. If we accept that domain closure is true, then we can accept that the query that we have, that there is no city connected to E, can be answered yes, because we are not only are we saying that it is not connected in our catalog or our database, we are also saying that there is no other city except for the ones that we have spoken about essentially. So, you can see that once we do domain closure, we are essentially converting first order statements into propositional statements essentially, because once we say that the domain is finite, only a finite number of elements are in the domain, we are essentially talking about propositional logic. So, now we can say that a sentence is entailed under closed wall assumption and domain closure, a sentence of the kind for all x alpha if the knowledge base and we can say that a sentence like there exists x alpha if instead of every we will say some. So, a formula like for all x alpha is true if it is true for every individual that I have stated in my knowledge base, and a formula like there exists an x alpha is true if it is true for some individual in my knowledge base. But this itself can lead to certain problems. Consider a knowledge base which looks like this. Some predicate with a constant C, a statement which says that no element is related to itself using the relation R, and the statement that for all x if p x is true, then there exists a y such that R x y is true and p y. If we have this as a knowledge base, you can see that it is consistent. There is no problem with this knowledge base, but if we do domain closure, is not consistent. Why is that? Because domain closure says that the only individuals that are there in the domain are the ones explicitly mentioned in the knowledge base, and the only individual mentioned in this particular knowledge base is this individual C, and there is no other individual. And now we have said that if you look at the statements carefully, first we have said that for every element it is not related to itself, which means C is not related to C, and then we are saying that for every element if p x is true, which is the case for C, then there exists a y such that R x y is true and p y is true essentially. Now, there is domain closure has precluded the possibility of any other element existing in the domain. So, it can lead to this kind of inconsistencies. So, we will see that whatever form of reasoning we try to do, there is nothing which is in some sense entirely satisfactory essentially. Every form of reasoning we will see will run into some kind of problems essentially. So, I want to move on to the next form of reasoning, which is called circumscription. And it is due to originally due to John McCarthy. So, you remember John McCarthy, one of the founding people in AI. In fact, he is the person who coined the term artificial intelligence in the Dartmouth conference, and he is basically a logician by nature. So, he likes to work with logic like systems, and he came up with this idea of circumscription essentially. Okay. Now, circumscription is something which is not as brute force as closed word assumption. You do not, in fact, you do not even modify the knowledge base at all essentially. You simply define a new form of entailment which is called minimal entailment, which we will see, but the basic idea behind circumscription is that the extensions by extension we will mean the image of a predicate or the interpretation of a predicate essentially. We will clarify this as we go along essentially. The extension of only a few predicates need to be minimized. So, to understand this, let us go back to closed wall assumption. It says that the extension of every predicate should be minimized. And what do we mean by that? So, let me write it here. So, by extension we mean the set in the domain that satisfies the predicate. And by minimized we mean keep only in some sense the necessary individuals. So, if you remember the city example, for example, which said that if we cannot show a city, two cities to be connected, add the negation of that to the knowledge base essentially. So, we are in some sense minimizing the so keep only the necessary individuals in the image of, let us say P essentially, whatever the predicate P is. It could be unary predicate, it could be binary predicate. In the example of cities connected, it was a binary predicate. So, if you want to look at the relation P or connected A B, then we said that the only things that are connected are the ones which are explicitly stated and everything else is not connected essentially. And the closed wall assumption says is that for every atomic predicate you do this essentially. Maybe we should mention this here, for every atomic here also. All this reasoning we are saying is whether certain predicates, no, what are they true for, which individuals are they true for. In closed wall assumption you say everything is that is not known to be true is false. Circumscription says that there are only a certain set of predicates that we need to minimize, and these are special predicates essentially. Blackman and Lewis call these the abnormal predicates, but that does not have to be the case essentially. So, circumscription is a form of reasoning in which we produce a new knowledge base. So, given a knowledge base, let us say the knowledge base is called phi. This is some notation which I am using from literature. You produce a new knowledge base which will be called circumscription of phi with respect to a set of predicates P essentially. So, the predicate P is part of the knowledge base, and we are simply saying that not every predicate should be minimized, but only certain predicates should be minimized essentially. So, as an example, let us start with an example and we will work with this example throughout this in the next lecture. We want to use the statement birds fly. Okay. Now, the universal statement was would have been, if we had used a universal statement, that for all x bird X implies flies X. And closed wall assumption should have said that only birds are the one that we know, and that kind of stuff essentially. But in circumscription, what we do is we write the statement as for all x, bird X and not ab X implies flies X. Where this predicate ab says abnormal with respect to the ability to fly. So, what circumscription says that you minimize this. So, supposing my knowledge base is this statement and some more statements. So, let us say bird Tweety, bird Chili, this is from Brackman and Levesque. So, everything in blue here is my knowledge base. It contains this one universal statement which uses the abnormality predicate, which says that how do you read that statement, that if x is a bird and if x is not abnormal, and by abnormal we mean that it is not able to fly, then you can infer that x can fly essentially. So, obviously, anything which cannot fly is abnormal essentially. Abnormal is not something that we are explicitly stated in the knowledge base essentially. It is the predicate which comes with circumscription essentially. So, as you can see, because we have this thing, we know that Chili is abnormal. Because we know that Chili cannot fly, so we know that Chili is not normal with respect to flying essentially, because we know that Chili cannot fly essentially. So, given this knowledge base, what can we infer essentially? So, we only know that birds fly, we know that Tweety is a bird and Chili is a bird, these are names, and that they are different. So, very often instead of stating that they are different, we may simply want to say use a general statement which says that all individuals are different. So, that is called a unique name assumption essentially, which says that every name is unique essentially, every name refers to the same person. So, you cannot say that your college name is Suresh and your home name is Chintu, that kind of stuff is not allowed. So, if it is Chintu, it is a different person, and if it is Suresh, it is a different person essentially. So, that is a unique name assumption. We sometimes make it explicitly, but here we have stated explicitly that Chili and Tweety cannot be the same bird, they are different essentially, and we know that Chili cannot fly essentially. So, the extended knowledge base will contain so how do I write the extended knowledge base? I could write it like this. contains ab chili but not ab Tweety. So, I am trying to give you a little bit of intuition of how circumscription works. In the next class, we will give a more formal definition of circumscription and how this inference is actually made. But the basic idea is that certain chosen predicates, we have to minimize their extent, which means we have to minimize the number of elements or individuals which satisfy that predicate. In this case, the predicate that we have chosen is this A B predicate, which stands for not being normal with respect to flight. So, essentially we are trying to say that normally birds fly, instead of the universal statements that all birds fly, we are saying normally birds fly, as long as we cannot show that they cannot fly essentially. So, that is a basic theme in default reasoning, and here we have used a predicate called abnormal A B, and the way that we will do inferences in circumscription is that we will assume that only those individuals belong to A B which have to necessarily belong to A B essentially. So, in this example chili has to necessarily belong to A B, because we know that chili cannot fly, but we will say that Tweety does not belong to A B essentially, which means that it contains not A B Tweety. Now, you can see that the moment we have this not A B Tweety in our knowledge base, and what is minimized? Minimize the set of birds which are abnormal, and Tweety we have no reason to believe is abnormal. So, Tweety does not belong to the set of abnormal birds. So, it is not abnormal, and once it is not abnormal and we know that it is a bird, then we know that because of this and because of this we can infer that Tweety flies. So, circumscription is a effort to modify the normal form of logical reasoning by adding certain predicates whose extent we hope to minimize it. So, we will see in the next class that actually when we do this, and in one of the definitions that we will see of circumscription, we are actually doing reasoning which is of a higher order, because we are saying that the extent of the predicate is minimized essentially. So, we are talking something about predicates, modifying predicates essentially. But once we say that there are that normal birds are not abnormal, then because we have not said anything about Tweety, we can infer that Tweety can fly essentially. All we need is to somehow produce this magical formula that not abnormal Tweety, and we are saying that if you cannot show that Tweety is abnormal, then he must not be abnormal essentially, and if he is not abnormal, he is normal and he can fly essentially. So, we will take this up in the next class a little bit more formally, but that is a general idea of circumscription, that instead of minimizing all predicates, which is what closed wall assumption does, that for every atomic predicate, if you cannot show it to be true, it must be false. In circumscription, only for the chosen predicates, if you cannot show them to be true, they must be false essentially. So, in some sense that is more discriminating, it is more fine grained, and we will see how it does better than closed wall assumption, and then we will see of course, what are the problems it has essentially.